Yo, 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 good morning, good morning. We have a lot of errors here, so I'm just gonna jump right into it. Where we left off yesterday, in an unstable state. We're in the process of doing the activation texture. It worked, but we only used an object's world space position to colorize the texture. Now I want to try and do the same thing but with bounds. So that's where we left yesterday, and that's where I'm gonna pick it up today. It's very similar to 1 point. We just send in 2 points instead. Basically, it's gonna be one min point and one max point, and then we want to loop through each index inside of that 2D box defined by those min and max points, and that's about it. The problem is more related to calculating the indices given world space position, but it shouldn't be too hard. And also, let me bring up, we're gonna do some painting again. I want to do this in a nice way. We have terrain patches representing, or a terrain base is represented by terrain patches. And when you do it like that, you need to solve the issue of how to fix the seams between patches. Our solution is representing the same value twice, and we need to work with that approach here as well. Yo, what's up, Derek? So, if we have, let's say that we have a terrain base with, resolution 4 and subdivision 0. That will result in a terrain that looks like this. If we have a terrain base with resolution 4 but subdivision 1s, in that case, we end up with am I thinking about this wrong? I wonder if we end up with this. So 4 pixel values, but these are the same, so we pretty much lose resolution. I think that's how we do it. I'm not entirely sure, so I would love to, let's do this. Environment 128, so let's do 512.4. do we end up with here? Yes, that's true. Fuck, is this correct? 1, 2, 3, 4. Yes, we end up with 4 data points per line, but 2 of them are the same. So if we take, can I visualize this? It doesn't properly visualize. But I wonder if we do, yeah, height. But okay, yes. So 512. This is true. Data value, data value, data value, data value. So this one pretty much tells us how many data points we will have per dimension in the terrain. So if we have 4 and subdivide once, we will still have 4 real values, but we will get 1 less because we have this one. These 2 are representing the same value basically. But then it should be okay. We should be able to solve this with a simple loop. We can just go, so in this case we would loop between 0 and 3. 0, 1, 2, 3. In this case we loop between 0 and 3, but we use we subdivide this one, so we have 2. So we loop from 0 to 3, but we do modulus 2, so which means that we get 0, 1, 0, 1. Oh, this is beautiful. I wonder how it will be here. It should work here as well. 0, 1, 0. Yeah, it should work. Okay, so that's very good. That means that if we have a bounding box with min and max 0, 0, 2, 2, if we have a bounding box represented in global, parameters, we can just loop through it and it will convert them. But I'm pretty sure this should work. But not really, though. Good morning, Harukanan. Let's say that this one is also 4 times 4. That's not entirely true. Let's say that it's 3 times 3. We want the pixel here that affects this one to be the same as this one. Did you see the new Veritasium video about rainbows? No, I haven't. Is it good? You're probably wrong about rainbows. You know what? I'm gonna watch that one, and then I'm gonna tell my son all about it. It's gonna be amazing. Thanks for the tip. Love their videos, by the way. I'm trying to wrap my head around this indexing and overflowing and underflowing and whatnot, and I'm having a real hard time. What I'm missing here is that when we have it like this, if we represent it by pixels, it might be a little bit harder to understand. So let's represent it by vertices, and each vertex has a corresponding pixel in data, right? So if we have 4 times 4, we generate pixels like this. If we don't have any subdivision. If we have subdivision, however, we represent them like this. 1, 1, 1. So 2 there. Like this. These 2 pixels represent the same space in world. So if we have an object that occupies this, we get this point, and we want to fill those points. If we max this and min this, will we get the doubles? Probably. Now it's more like if this one is 0, oh, fuck, this is hard. But if we take global indices, this one is 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. But when we calculate the global, we get this one. So if we have this box, we pretty much only get... Yeah, we only get this. But if we do max on this one, we also get this one. So then we get that one. If we do... Yeah, if we do min here, we get this one as well. That's true. So maybe that's all we need to do. Yo, what's up, Geralt? Good morning, good morning. But yeah, what sucks is if we have something that we have a marker that goes like this, so just this one, then we don't get this one and we're fucked. But we could also do... How could we do this? Like, I'm spending a lot of time here to solve this in a very nice way, because if we can solve it in a very nice way here, we get that for free in the water fluid solver as well. It's basically about... We want to work with global indices, but we have this weird little offset to keep in mind. When we calculate so bounds here are in world space, we offset them to be in local space according to the terrain base. And then we do this calculation. This calculation pretty much gives us integer indices by this structure, not by this structure. And then we need to calculate a transform in some way to transform from this structure to this structure accordingly. It would be easy to solve in a case like this. We could just do max and min, or could we? Yep, maybe. Yeah, if we did it with, yes, min and max. But what I'm afraid of is when we have an overlap that pretty much slices exactly at one of these points. This point and this point represent the same data point. They have the same data and they are located in the same space. But by calculating the index like this, we don't get this one. Eventually we might actually want to handle this per terrain patch as well, so I wonder if we want to calculate I don't know if I want to use... It's pretty much exactly, let's see here, terrain patch terraformer, terrain patch, not really. And maybe this one. Brush radius. We could do it like this. Basically what it does, we're gonna add some extra calculations, but it calculates a bounding box per terrain patch affected, and we get the double points as well. I'm just wondering if it's the best way to do it. We could do, I think, yes, what the fuck, we do, so if we get, let's say that we have a box here, then the global coordinates will be from, let's just solve the upper one, because this one, if we have this one subdivided, we should take this one into account as well, but this one doesn't overlap it. So in X, this one will go from 0 to 0 to 1, but then we add an offset here as well that is equal to plus, we calculate something here that is 1 if we're at the edge, 0 otherwise. And we need to calculate it if we're by the edge by doing, we do we take the index here. I wonder if we can just take the index divided by index by subdivided resolution minus 1, which is 1. This one will give 1 here, so we will add 1. If we're at 0, yeah, we can't divide with 0, but yeah, but it's actually we wanna loop through min minus offset to offset. Let's call offset u to max plus u, and we just need to calculate u in some nice way. It's basically, we just want to check if it's the max, or min terrain patch coordinate, but we don't want to do it with ifs and else. So for the max one, we should be able to do but shouldn't we be able to do index divided by index divided by resolution minus 1 r minus 1. So this is resolution subdivided minus 1. So for 0 here we get 0. For 1 here we get 1. And then we want to do modulus this one with 1.0. And then we do an if and else, but if now we can, yeah, if this one is greater than 0 and this is our offset. 0 by this one is 0, it's not bigger than this, so we get an offset here. Fuck, I want to test this basically. So we do minus 1 here. Yes, I think we should be able to do it with this one. Or does it exist a better way to check if something is a full float than this? Check if float has no decimals. Yeah, exactly. Yeah, maybe we might need to do this event. Yeah, maybe. But then again, we're working with integers here before, I think. So we're gonna have to cast a float. Yeah, we don't want to do this with float values. We want to do it with integer values. So we could probably just do, yeah, what the fuck, I modulus r minus 1. Oh, so much better. If this one is bigger than 0, that should be the offset we can get. I r minus 1 bigger than 0. That's our offset here. And that's our global indices. But then again, I'm not sure. Oh yeah, I am sure this will work. But if we get this one, for instance, yeah, it's gonna be a problem when we want to go the other way around later on. Maybe it's okay. We will get all the points of interest by doing this at least, but so I think so it will work for our solution right now, which is binary. But when we move on later on and we wanna alter the, we basically want to alter the vertices or the data points based on how much they are occluded, then we might get some problems. I really do want to avoid to do too many calculations here, so going back and forth between spaces and stuff. Let's just try this one, see if it works first of all. So min index round to int. So here I basically want to do min index dot x is equal to, or minus equals to, min index dot x modulus, let's do this one, resolution subdivided minus 1. Equal to 0, right? Oh, come on. Can we do cast like this in... Oh, fuck me. Which means that we're gonna have an if else here anyway. And another thing we're gonna have to do max of 0 and this. Can we do f clamp? Because we don't want this to, we don't want to go below 0 here. Do we have float int? Okay, beautiful. Mathf max 0 and whatever we return here. And then we want to do min index dot y, the same thing. We can probably skip these as well eventually. Resolution. Like this. Because what we can do then is we can simply do for int I is equal to min index x, I is less than max index dot x plus 1. In fact, we don't want to do plus 1 here, or it would be nice to skip it. Can we just do it like this then? Maybe. And in here we just add it to the proper ones, so much like this. Yo, what's up, Norin? But then it's about getting terrain patch index and getting terrain point index. So now we have a global terrain base index, and we want to transform that one to a local terrain patch index, basically. Round to int, we don't need to do round to int. Or maybe we do. And basically everything what we have here is just this one, but taking into account that 2 points can represent the same value. Fuck, how bad are all of these calculations? Pretty bad. We don't want to do this here. Do we want to do it here? Yeah, we do. And then we do terrain patches. In fact, do we want to do floor to int? Yeah, I think so. Mathf. Now we're gonna do integer division here. I just need to double check. Division C#. We should be doing floor by default, right? Rounded towards 0, beautiful. So we might as well terrain patches I divided by resolution subdivided. 128, 127 is 0. Yeah. Resolution subdivided. J resolution subdivided. Dot set activity. And yeah, we want to do it like this, right? We want to set activity, and I want to change terrain pet set activity. There we have it. And here we just do I resolution subdivided. Does this make sense? I think so. There's a lot of things that might go wrong here, but let's try it. So update activity, what we do here is we do, let's fix this one first. We just want to call bounds. Fucking hate what I'm seeing here. Are you serious? Okay, that explains it. We're setting a lot of values. It's a little bit too big. And then we go outside, we get some error. Makes me wonder if we have, yep. I think it's the, okay, pants, we have something wrong with the pants. And tracksuit. Fucking box collider. I knew this scale, wrongful scale, would come back to bite me eventually. So when we have a sweater on, we have a scale of 111, but when we don't, it's way too big. Honestly, this one should definitely be, this one should be disabled right now as well. That's for sure. If we disable this one, oh, that fixes this. That's better. We still have the boots as well. I definitely want to disable these. So now we should only have the character bounds. I need to double check the colliders for the apparel. This one sucks a bit. What do we have on the this one? Okay, we actually get this one here. We don't get this one here. That's weird, however. Makes me wonder. This one is a little bit screwed up as well, but it does... Where do we have our... We can double check it like this. Here. Looks all right. Looks good. Ah, this sucks. Don't want to allow for this. So what we're seeing here, I was hoping we would have gotten rid of it. And why is this one skewed in such a weird way? Not calculating the offset properly, maybe. Oh, we don't take... Yeah, we have one offset issue with these, and yeah, we want to be more precise eventually. Yo, what's up, Cooler SK? Yes, we have a little bit of an offset going on, that's for sure. Only in X direction, though. Is that true? Yeah, only in X. Trainer Taz, what's up? I'm always looking for new Creature Collector games. Nice. Yeah, we only have an offset in X. That is wrong. Interesting. Fuck, I just want to start doing snow with this one. Feels like it's gonna be quite straightforward. Okay, that's the first step. I wanna check. I wanna get to the bottom of this offset here. Fuck, is it in the X direction now? It's both in Z and X. Yeah, I might know why. But it's always in the maximum. Probably has to do with this one I added here. Yeah, we don't want to add this. Second of all, okay, before I play again, we wanna fix this or try with 0-1 here, or 1-0. And I also want to fix the apparel. We should disable the colliders, encapsulate. We only do it for each collider. Start. And entity enable physics, false. They should be disabled. Is trigger. Yeah, we're gonna have to clean this up eventually. Maybe set them. Yeah, we're gonna do it with this, but anyway, we want it to be enabled, and C is trigger is equal to is false. We don't care about trigger colliders. The FPS is going to be a giveaway. I wonder why we have such high FPS here, but anyway. We still have a little bit of an offset. But now we have it in the other direction. Huh. Negative said, negative said positive. Yeah, we should be getting these. Yeah, we should be seeing all of these. I wonder if the problem actually lies with round to int here. Here we probably want to do floor to int and max to int. Or ceil to int. But. For this one, I would say that we're getting... Oh, we might need to add some offset here as well, yes. That is true. Yes. We need to add... We need to scale it. Yes. And add an offset. Yes, I think so. Yeah, we do. We need to scale it because Am I thinking about this the correct way? Yeah, we have one more vertex. Yeah, we need to do not this. Bounce step. Yeah, I have to check step here. Step is equal to delta. And delta is equal to dimension divided by resolution minus 1, yes. And step we need to do instead of doing divided by dem. This is probably a better way to do it. Circle origin. Yeah, let's try this instead. But yeah, it should work. And let's see what kind of result we get for this. I'm not entirely sure, however. Because then again, it worked for terrain patch, but I mean the offset should be the same. Or not. Of course, we need to do this offset first of all as well. Fuck. Oh, yes. Dynamic entity. Interesting that we didn't get an error from this previously. Interesting. This one, we don't want to do it for dynamic entities that are disabled pretty much. Because in this case we get a dynamic entity that doesn't have any new bounds, transform position 0. Still shouldn't get an error here, I don't think. Enable physics is kinematic. So if this one is false, yeah, so we want to do but still I'm wondering why we get those errors. Hopefully we shouldn't get them from the shoes this time around at least. Let's see. Pillow. Yeah, okay. Yeah, that makes more sense. So what do we do here? We take the position in world space and add half a dimension to them, and then we divide by resolution -1, and then we round to int. Oh fuck, that's true. Yes, this one only, what? Did I miss something in how we solved it in Terraform data? Because this one should yield circle origin. Yes, I think yeah, we do some calculations here. Yes. Dimension and resolution, they don't match. So we need to take that into account, which we did here. So I'm wondering, is the only thing we're doing here is that we should be let's go back to this solution, but let's see if we can get an offset working here as well. Terrain, new terrain transform, terrain offset. Fuck, is this the best way to do it? terrain offset. We use offset here and we use offset here. Does that make sense? Wonder if we want to add offset. After this. I'm gonna try. Now I'm gonna have to go back to the drawing board with this one, with this offset. And I want to see what this looks like if we skip this doubling. Yo, what's up, TM? What are you working on today? We're trying to get this activity texture to work properly, and then we can hopefully polish it. So I'm talking about this one. We want data points that are occupied by objects to light up accordingly. But yeah, we have a little bit of an offset problem currently. And back to the drawing board. I wonder, like in this case, we would like to have Z, Y. Oh, come on. I mean, minus 0.5 f. Yeah, that's what we tried. Something similar with the offset variable. So is this for foot trails and stuff? Yeah, basically. It's gonna be for quite a lot of stuff. (0.5 times whatever grid spacing, yes. It's only this one missing here, is it? Me, obviously have checked this already, and I thought I did. But we're probably doing it in the wrong way. Let's see if we can get this under control. We're gonna paint it like this. Let's see. This could probably already work if we don't have patches. vertices, texture pixels, even though it isn't really texture pixels, but yeah. And if we have a point here, but fuck, this is not entirely true either. Okay, this is just with one terrain patch. Yeah, it would be easier if we initially just clamp it to this point, exactly as we do it in Action Terraform, I think. Terrain offset. Terrain offset divided by terrain delta. But then we do it again. Now I want to wait with doing that because eventually I want to be more specific with the points we activate. I may look like you're only off on one axis. Sometimes that's the case, which makes this a little bit more annoying. Let's see. So in this case, I guess we would be getting, these lit up and these lit up as well. So it's negative Z and positive X in this case. Here, on the other hand, we're getting one less in negative Z, one less in positive. In this case, actually, we're getting one too many in negative X. Yeah, currently we have we probably want to replace this one with round to int. No, we don't. Yeah, probably we want to. We're gonna try with round to int here instead. Currently we do floor for min, ceil for max. I think that's stupid. This was mostly... The reason we did this was because we wanted it to work with I thought it was an easy way to manage terrain patch points that are, or pretty much to manage terrain patch overflow. Let's just do this under this face. Yeah, now we're always one too short for Z and X, right? That holds true for all. Not in this case. Oh, actually, we might be. Yeah, we might very well be. So one short in Z and one short in X. In the positive direction, always. I thought. Here we want too short in negative. I mean, any chance you have a debug drawer for axis below the place so we know the coordinate system? I don't have a custom one, but we have the Unity one. Yeah, Unity one is in world space. This is what bothers me. Yeah, so here we're probably one short in X and Z, but we're also in negative Z. And negative X. But is that because of... No, it's not. And what problem did we have if we did... I assume you want all the squares in the radius. Yeah, basically, right now we... we just care about bounds of colliders. So we take all colliders for this character, calculate bounds, and then we just use a min and max point. So we're not at radius just yet. So you're getting an overflow on the negative z axis. Yeah, but we're not getting... Yes, right now. That's the case. In this case, we probably get an overflow in negative z and positive x, I would say. We can't show ortho top down because the shader stops working in that case. Would be extremely helpful, so maybe we should just get to fixing that one. Honestly, I have no idea why it stops working, or why the grid lines stops working. It probably has to do with... I'm pretty sure it has to do with... grid alpha. So if we just do... Nope. Or maybe if we do... I have no idea why we don't get the grid lines when we're in ortho view. It's weird as fuck. But then again, it's probably easier to go with... Yeah, these two probably highlights the problem we have way better. To me, it looks like we don't get enough. We don't get enough on x-axis, both negative and positive, and we get one too many on positive z, at least for this one. Yes. It's the same for this one. We could do it... I think we can do it like this. Let's do this. Let's simplify it a bit by doing... where do we have it? Entity... private void on draw gizmos draw cube center size bounds and unbounds.size, right. I mean, you're using a round or something when you maybe should be using a clamp. Yeah, it's probably something related to that we have. There's a lot of transformation between spaces and index types going on here. Do we have... oh, what the fuck? Yeah, we want to draw a wire box as well, not a box. Or draw a wire cube. It feels like it's gonna be a little bit easier to figure this one out if we have some proper debug boxes. Why don't we have one for our character? I think I know why, but we can use these properly if we do... this should make it a little bit easier to visualize. See, I think at this point I would like these to light up as well, so we're doing one too little on the x-axis here, both positive and negative, and we're doing one too many on the z-axis. That's pretty much it for this one at this position. As for this one, we're doing one too many on Z, just like this one, but we're doing the proper amount on X. Drag it, yeah, that's a good, that works pretty good. Here we have a terrain patch issue, which we haven't fixed yet. But yeah, so you can see here, it's when we reach half the point that we start lighting it up. This one is weird. In the positive, we're one half too slow. In the negative, we're one half too much, right? I was hoping that so this is X. Let's take a look. Let's really take a look at what we have here. So for X, for positive X, we're half a square too slow, right? And on negative X, we're one half too slow as well, but we have an overflow of one as well. So, or actually, are we? Yeah. Or am I getting that right? Yeah, 1.5 too slow. 1.5 in negative X, 1.5 in, or 1/2 in positive X. And on Z, yeah, so we're one off in X, that's good. And in Z, what do we have here? We have the same thing, but in the other direction, right? Yep. So we're one off in X, we're one off in Z, but in Z it's the opposite way, pretty much. The difference in positive and negative is probably because of this one right here. So I'm guessing we want to round here and add an offset. I thought this offset would be enough. So if we do this same test, but we do it with round to int instead, what did we have then? I wonder if this offset we're adding does more damage than it helps currently. Offset is half the distance of one grid in world space. If I remember correctly, we can double check it soon. So in this case we get in this case we're perfect on the negative X, but one too slow on the X, right? Perfect on negative, one whole square too slow on the positive. Is it the same for Z? It's probably the other way around. Yeah. So in this case we just need to add one negative Z, positive X. That's what bothers me. Yeah, we're inclusive in the negative direction for X, but not in the positive direction. And for Z, we are inclusive in the positive direction, but not in the negative direction. I'm just gonna do one last test with removing this offset from here. Inclusive in the positive, yeah, it's the same. Yeah, with this offset you can see here that it, let's see, does it do anything? Yeah, 'cause it do anything? yeah, now we're just, yeah, we need to add one to positive x, and we need to add one to negative z. That's pretty much it. Yeah. But I wonder how this could be. It's pretty much, we want this, let's see here. We want this one to be one more, and we want this one to be one less. But why? So this one less, and this one more. But I think I know. We're currently in patch 01, so we have one more on X, and we're I wonder if that, let me do this. Environment 0. Yo, what's up, caveman? How are things going? They're going. How about you? Yeah, okay, so if we only have one patch, we need to add the offset, right? Yes. In both directions. So if we only have one patch and we have offset. Okay, man, I'm working on my AI VTuber pet project. That sounds pretty fun. I'm pretty sure, so some other part of the pipeline screwing you always, to answer that question, but I'm pretty sure this has to do with the patch system. We're just not taking it into account in the correct way. So it should, if we have offset, we don't get, okay. Yeah, because then, okay, so the offset here, how do we calculate it? Offset is 0.5 times delta. Delta is dimension subdivided, resolution subdivided. Yeah, that's probably not what we want to do. We want to do, we still shouldn't get a problem here. Actually, we don't want to use delta here. Resolution subdivided. Subdivision is 1. Resolution subdivided in this case is 512 divided by 1, so 512, 511, dimension subdivided. $512 divided by 127. No. 128 divided by 511. That's our delta. Does that make sense? Yeah, probably. 0.5, offset 0.12. How many facets does the patch system have? What do you mean by facets? Yeah, round to int probably screws us, because if it's even, we round up. If it's uneven, we round down, right? So that one is probably fucked. Okay, when the patch system is like an onion, it has layers. It definitely does. Facets parts that make it work, I think it's just one. We have a terrain base and then we have terrain patch. But in this case, pretty much, yeah, I'm pretty sure all we need to focus on is on terrain base. It sets up everything accordingly. Clamp is probably better. Caveman, and it makes you cry? Not yet, and hopefully not later as well. We'll see about that. Also a little bit about this offset here. Yeah, fuck it, let's do... Actually, shouldn't we just do this? And nah, one sec. Yeah, if we cast to int, I guess it rounds towards 0, and then we might need to go +1/+1 in XZ direction. We'll see. Fuck, am I rounding this the wrong way? Let's see. Why didn't we get anything this time around? Float. Yeah. Let's try and move these in here. Actually, do we want to move them in there? Yes, we do. So bounds min x, bounds min z are world position coordinates. We do plus 0.5 times dimension to pretty much bring world coordinates into object space. The terrain is offsetted by half the dimension. We pretty much remove negative values by doing this. But where the hell does our activity disappear just by doing an int cast here? The fuck? I mean, can you breakpoint and check that at the origin that your values make sense? Not entirely sure what you would like to check with that. So the thing is, we had this working with single points yesterday. So just sending in a vector 3 here. But now we want to do it with bounds instead. Yeah, of course. 1 sec. Or yeah, we should be able to breakpoint in debug mode. But what I want to figure out now is why don't this works but math round to int works? I just must be doing something a very basic error here. Math round to int for this whole thing. Yes. Let's double check this before we do anything else. And now it's just a question of not being inclusive in the positive x and positive z. Yes. Right. Yeah, there we go. And we should be able to fix that easily. So we should be able to do it just like this. Wonder if we get any other problems eventually. But once again, this is only for one terrain patch. Maybe it's not too bad. Maybe it's not too bad. Looks to be all right. Yeah, I think so. We don't have bounds for this character, however, for some reason. But yeah, everything looks good. Let's see what happens if we involve some terrain patches here. Yeah, we're not gonna get the, so here we do, so for this terrain patch we involve one, let's see here, this terrain patch. X is offsetted by 1 in the positive direction, or 1/2 in the positive. Yeah, 1/2 in the X direction and 1/2 in the Z direction. Or no, what am I saying? 1/2 in X and 1/2 in Z. One half. Yes, okay. It basically has to do with the fact that we... So the question is if this can fix it. And I want to test one more thing. Does this mismatch hold when we change patches as well? No. No, it doesn't. So here it flips. So we're offsetted 1/2 in the negative x. This one holds, but if we jump up 1, it's probably going to be the other way around. Yes. Yes, we need to fix that. I wonder if... this won't help with that. Or I wonder... before I continue, I just need to run AFK real quick, so I'll be right back a minute or two. Back, sorry about that. I just want to test, let's add one additional patch and see how it... oh fuck, do I have one of these issues as well? Oh yeah, on draw gizmos, whatever. Environment 2. Does this... the error we get pretty much, does it transfer does it get bigger and bigger the more patches we move? So here we move a patch in the positive x and we get drag in the negative x by 1. And if we go to the next patch, do we get more drag? I don't think so. No, we don't. It's still just off by 1/2. We're actually... 1. .1 clamped is 0. don't know if that's the problem we're having. Here it's 0. Here it's a half. And here it's 1, right? 1.5. Interesting. It's pretty much, so when we do terrain patches, we have, you can see it here. We basically, for this terrain patch, we have some data here. And for this terrain patch, we have some data here, and they share. We pretty much, for each terrain patch, we lose one index-ish. Or we want to do an offset that is now there's no difference between this patch and this patch, right? Oh yeah, it is. I also want to avoid this. I don't want to have half data points. When this one is lit up, we want this one to be lit up as well. I wonder if I want to try, let's re-add these two and see if that fixes the half light ups. Okay, no, it doesn't. Okay. Although, one sec. Basically what we're doing here is, if max index is 0 or a if it's 0 or a multiple of resolution subdivided minus 1, this one I'm not so sure about. Nah. So if we have an index of 127 and that's it for the full patch, so this one is equal to 0, then we add 1 to max index. So it becomes 128 pretty much. So as soon as we set 127, the index of 127, we also want to set 128. So I don't really see what's wrong with this. Or rather, why this wouldn't work. So instead, this one is 120. Is it 127 we have now? 512 divided by 4, 128, yeah. So this point right here is index 127 in y coordinate. So if we get a max that is 127 here, so then we check, this one is 127, 127 modulus 127, we get 0 here, it's equal to 0, we return 1, so we just add one index here. So instead of going between C and 127, we go between C and 128. But that's not what I'm seeing here. What I'm seeing instead is we do it a little bit too early, right? 127, is this 128? Floor, what do you want to floor? I'm me. I'm pretty sure this is index 120. No, it's not. One sec. Yeah, I'm pretty sure it should be. Each patch should go from 0 to 127. Resolution subdivided. Yeah, 512 divided by 4, 128. Yeah, we definitely need some offset here, I'm pretty sure. Yo, what's up, Cynic? We're working on a activity texture, basically. So we want to light up. So given our terrain, we want to keep track of where we have objects and how they move and stuff like that. Just trying to get this in place today. Oh yeah. This should definitely not start lighting up when this one does, but this one should start lighting up when this one does, which bothers me. I want to see what happens if we remove this -1, even though it doesn't make any sense removing that -1. I don't think. Or fuck, does it? Does it? Maybe it does. This looks good. Ish. And this looks very good. Fuck yeah, so does this. It shouldn't be. Let's see here. 1/2 too slow, 1/2 too quick. Yeah, I think we need to calculate an offset based on how many terrain patches we have. Does that make sense? Does that make sense? One sec. Or actually, we should only... Yeah, we just want to do exactly the same thing we're doing with this pointer, but we want to do it... Yeah, it should be easy. But we want to do it with 2 points. So when we go here... Yeah, and then we want to do the flip over, yeah. And when it comes to the point, what do we do with the point? We do action terraform. We have a world position. We add terrain offset to that world position. Terrain offset is offset in terrain. Then we divide by terrain delta. We do times terrain delta, then we do minus terrain offset. Does this make sense? I want to try doing the same thing for our activity. Here we do round though, and maybe. So then we have the brush position, terraform brush, and what we do with that one later on is we do... yeah, in this case, I think this round is good. Why does it make you feel ill? But what do we do then? We do... transform. It's not good for integers. Yeah, maybe you're right. I think we can do... I think we should be able to clamp this one instead. But basically what we want to do is we want to do this offset. Because this one, it transforms a position... Let's see here, terrain delta. I think this one transforms a world position into a global grid position. Apart from the fact that we don't... Yeah, let's just do this. We wait with doing this one. We do it later on. And we do transform inverse transform point here as well, but it should be okay. Yeah, it should. I want to try with this one. So, yeah, this is our position. So what we want to do with this one is plus offset divided by terrain delta. Delta offset. Oh, fuck. around here interests me. Fuck it, let's just try it. Min is equal to, and I'm just gonna copy this one. Let's copy all of it. Math of round. Let's do new vector 2. Bounds.min.x offset delta times delta minus offset. It's some form of truncation, and then we take this one here and we do max here. We could probably do this as bounds.min plus offset, whatever. Like this, min and max. And the only thing we want to do here then is probably I just want to we want to bring it to int, but I think the only thing we want to do is min plus 0.5f times dimension. No, not really. This is what worries me. I mean, why don't you just clamp to int and subtract 0.5? Instead of what? And add 0.5. Are you talking about here, right? Or? Why don't you just clamp to int and subtract 0.5 and add 0.5? We'll think about the square at 0, 0 to 1, 1. What's the result you want from that? If you solve for 0, 1, you have it. I don't think we do. What you're talking about, me, if I'm following you correctly now, you're talking about... Fuck, I don't know if I understand you correctly. If you solve for 0, 1, you have it. Cynic, how does it even work? Do we just project X and Y position down to the ground, find local position and do some shitty magic to draw squares? Let's take a look at the full pipeline so we get a full scope of the problem we have at hand. Basically, what we want to do is we want to take any point in world, so by X, Y, Z, and yeah, we project it down to this plane by simply removing Y. So we just care about X and Z. So then we have a position in world space between XZ plane. What we then want to do with that point is that we want to transform that point to world space to an index space for this full grid. And I'm talking about these smaller grids, not the bigger ones. So we want to bring a world space position to grid space position, and I refer to it as a global index, because what we want to do then is we want to take, so for instance for this, so for the world space position in the XZ plane, we want to transform that world position to be an index between 0 and 511, because that's the full resolution we have here. And when we have that, we want to transform that index between 0 and 511 to an index between 0 and 127, because that's the indexing we have per terrain patch, but we also want to be able to handle overflow like this. So index 127 for this patch is index 0 for this patch. And when we have that index, we can change it in a compute buffer and send it to the GPU. The GPU will then unpack it, transform it from that index to normalized UV coordinates between 0 and 1, and that's when we can draw which square spaces that are actually activated. That's pretty much the full extent of it. These terrain patches screws it up a bit, but it shouldn't be this too much. And I'm very interested in what you mean by if you solve by between 0 and 1, because I think you might be right, but I'm not fully following along, if you get what I mean. Basically what this does, it truncates a world position to, it truncates a free-flowing world position to the vertices or the data points. But let's see, I know that this one works, and this one works for terrain patches as well. I don't like the round. Yeah, let's take a look here. Do we have any errors? So just what I'm trying to do now is that, yeah, previously we pretty much had this working, but the full pipeline was a little bit different. We split it up into different terrain patches way earlier, which eventually makes it a little bit more unoptimized. Now I'm just trying to skip that step and do it just at the end when we need to do it, if we need to do it. So basically the point we see here, the mouse pointer, this one transforms or it pretty much just truncates a world position to fit on this grid. And the position it truncates to is perfect. So like it's right in the middle of each data point. So in my mind, we can see here it also works. Here we are between patches, and it works here as well. It takes the middle of it. Having bounds like we do now is no more different than having two of these points. So I just want to truncate the max and the min. And that's what we do here right now. We truncate the minimum point and the maximum point. The only thing we should do now is transfer this from world space to local space. And local space, I'm talking the full terrain patch. We just want to bring up values that are negative, what is it? 255 to be positive 0. But dimension, okay, so when you're talking about the 0,1, that's just truncating it. Yeah, so that might be better. I guess why you don't like this is because it might floating point errors might fuck things up later on. But round 0.1 will be 0, right? Round 0.9 will be 1. In this case, that's what we want, because here we just want to truncate it, right? So basically all this one does is actually what this one does is, let's say that our data points in world space is located at every 1.5. So for x it's 1.5, 3, 4.5, 6, and so on. What this method does, it truncates. If we have coordinates that has an x, if we have an x coordinate of 1.65, it truncates it to 1.5, 2.75 truncates it to 3.0, and so on and so on. Rounding isn't good for graphics logic. trunc 1.65 is equal to 1. Like not in this case, like what these full lines does this truncation. Yeah. If we take a look at it, we can see here that when we move like this doesn't truncate it to full integers. This doesn't care about integers at all. I'm talking about the full calculations we're doing here. So this one truncates it to be equal to, it truncates it to our data points in world space. And I'm talking about this full line, not only this one. I know that round doesn't truncate. I'm talking about the full, like this full calculation is a truncation. Like when I say that this truncates this, I'm not talking about that this one truncates it. I'm saying that this truncates it. I don't know if my terminology is wrong or where the mismatch in communication happens, but this full calculation do we have why mathf trunc, because we don't have that. I was a little bit afraid there. So basically what this one does is we have we have a grid in world space. Okay. Let's do it like this. How these points are distributed in world space depends entirely on our environment setup. It depends on a variable we call fuck do I call them? Dimension and resolution. Resolution decides how many points we distribute in each dimension in world space. Dimension tells how far the distance between the first point and the last point, right? So what these calculations does is that they take one point in world space and truncates it to the nearest grid point. Harry Heath, rounding is fine, it's not integer math. Yeah. Exactly, and I mean that's the result we want in this case, because then we do things like this. So this full calculation truncates our if we have this point in world space and we want to truncate this point to this grid point. Remember, this grid point right here, right now, this grid point doesn't need to have an integer based position. Like this grid point might have a position in world of 3.5, 7 point, I don't know, 5 as well maybe. So in this case, this one might have 3 point, or actually it might have 4.2, 7.9. That makes sort of sense, right? We want to truncate this point's values to follow the rules of the grid, basically. So we want to move this point to this point. And that's what we do here. If we had the point here, we would like to move that point to here. We haven't begun working with integers just yet. We're still in world space. It's just that we want to truncate it to grid points represented in world space. Eventually, so the next step here, after we have truncated it, is to transform it to an int index. So let's see what we have. So we're still in world space here. So what I do here, like from now on, we might have some errors. I know that this works. We get the correct truncation here. But from now on, let's see what happens. So first of all, I want to do min.x, min.z, or y. So what I do here is I move, so in world space position we might have grid points that are located in the negative, with negative values. I just want to offset all of these to the positive. And we do that by doing plus 0.5 times dimension. So now we have values between, but this one, let's see here. Yeah, we might take some shortcuts eventually here. Actually, the only thing we're doing here right now, I'm not entirely sure I like this. It feels like we're doing too many calculations. We could probably skip some. But here we truncate. Let's try it. In fact, I wonder if I want to do this. here we truncate the coordinate. Here we transform it from world space to index based. Let's just see what this yields, honestly. The only thing I would have against this is that we do the truncation too early. But I don't know. Yeah, but it still gives us problem with... No, actually, let's see here. I'm pretty sure this works. Pretty sure. And it works over, maybe not right at the edges, we're gonna get to that, oops. But probably, what do we have here? Yeah, it works. And it works for terrain patches no matter where they are. This one we want to fix, 1 sec. But yeah, no matter in which terrain patch we are located in, we get the correct result here. As soon as we don't go over a terrain patch, I was about to say, but it works in this case. Are you kidding me? But not in this case. So this we need to fix. And I think I know why. 1 sec, phone call. Okay, back. Sorry about that. Let's see. What do we have? Yeah, it works perfectly everywhere, but except for when we move backwards. When we move, what do we have? Yeah, when we move from one terrain patch to another, we get the correct data here, but not when we leave one. So it's the 0 here. I wonder why though. Yeah, I think I know why. It's because of this one. Or, yeah, maybe. I thought we would need this and this to solve this issue. What I want... Let's see, let's try this. I want to see what happens if we do... Yeah, if we go outside here, will we get an error? Yeah, we will. Okay. So I'm wondering... Max index here. I'm pretty sure we want to do this, but that will screw with us unless we do... Yeah, I think I want to do this, and then I want to do this, but then here I wonder if the correct solution is this. So we're always extra careful when we do the... Fuck, does this make sense? Let's just see. Yeah, looks good. This doesn't. Okay, so it's just this specific issue we have. Crossover calc on the yeah, exactly. It's only the positive, right? Yeah. Negative works. Right. That makes me want to do 0, 0, but if we don't add one extra, aren't we gonna get... maybe not, maybe not. Now I'm afraid that we're gonna miss out on, but probably we won't, Or? Yeah, if we don't have +1 there, since we're doing less than now, if we don't have +1 for all maximum indices, we're gonna lose 1 in the positive direction. Unfortunately, we're gonna get it. So here it works. Because we add 1. What the do we just want to do on the positive one? Do we just want to do do we always just want to add 1? Whoa. Yeah, plus oh, what the fuck, I'm stupid. 1 sec. I've screwed up here. We don't want to do minus equal to here. Oh, what the fuck. I don't want to have less than or equal to here, because then we're gonna have we can go out of bounds. If we go out of bounds for the full terrain, we're gonna get some errors. It's just that I want to add 1 eventually, so it's more gonna be like fuck, I think we want to do this. We want to do equals to oh, we want to keep equals to 0. Or actually, what I'm wondering is, so basically what I want to do here is I want to, if this is true, then we're overlapping, so then I want to do, we want to do it like this. Basically I want to do min index.x sed max. I want to do something like, oh, not sed, y. And if this is true, what I want to do here is mathf dot max min index 0, and here we do want to do mathf min resolution -1, and here we want to do -1, and here we want to add 1. Not too sure about this, but let's try it. Harry O, how are you setting values when they're on the edges? Looks like when setting 127 it sets 0 and 1 of the next one. Yeah, exactly, that's what it looked like I'm gonna explain it. I'm just gonna see if this works first. It might not be the prettiest way to do it. Please. Ah, fuck me. Oh yeah, because we want to do... Yeah, this is the weird part. Now it's exactly how I... let me just do this. Makes no sense, but... Let's see here. I'm gonna try to explain it soon, Harry, my train of thought for this one, and we can see what we get. Okay, let's see. The grids, let's see, 20, yeah. So the grids we have, if we have a terrain with points, we have a terrain, it's just one patch, we have 4 times 4 points, then it's pretty much distributed like this. These are our data points for our grid. If we then subdivide this grid, so we still have a grid that is 4 times 4 point like this, but we subdivide it once. What we do, which I'm open to suggestions here, but because I'm not entirely sure about this solution, but basically what we do is that we don't add more data points when we subdivide. We just let 2 data points represent the same data. It's to make our seams work. It might not be the best solution. So basically what happens when we subdivide this one once is that we transform it to a grid that looks something like this. Bam, 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 bam. Like this. So basically we have, and these are close to each other, they are actually on top of each other in our solution. I just drew it like this to make it more apparent, which means that when we subdivide, we have the same amount of data points, or no, we have the same area, but represented by less different data points. Fuck, does this make any sense? So basically here we have an area of X, Y, represented by 16 different data values. Here we have an area, the same area, X and Y, represented by 16 data points, but some of those data points represent the same data. So what I'm doing here now when we move something over the patches is that I'm trying to work with global indexing. So this one have index 0, 0, 0, 0, 1, 0. I'm starting to get tired. 0, 2, 0, and 3, 0. What I try to do here is I try to work with those same global indices. So this one has 0, 0, 1, 0, 2, 0, 3, 0. But when we're setting the actual value later on, we transform these to local indices. So this one will still be 0, 0. This one will be 1, 0. This one will be 0, 0. And this one will be 1, 0. To be able to do this in a nice way, ever-flowing way, basically what we do here is, if we have an overlapping object and we notice that the max x in this case, if we notice that, how should I explain this? It's basically, we have this overlapping object and it has a max of, its max coordinate is 0, is 1, 1. Then we just double check here if this global coordinate can possibly represent two different values, which it can because it's the resolution subdivided -1, it's equal to this one. That means that this index represents two values. Then we just add one global value. So instead of having a global index of 0 to 1, we get a global index of 0 to 2. And then when we do this modulus here, when we split it up into separate terrain patches, this will be handled nicely. 0 and 1 will represent terrain patch at index 0 on the x, and 2 will represent the terrain patch index at 1. Fuck, this is... It might be a very complicated way of doing things. This is so I get overlap. It might... It's pretty much, I always want to work with, is there a particular reason why you want this? Like, it feels like if you want to do terrain represented by data under the hood and you want to split up the terrain into terrain patches, there's really no other way around it, is it? You're always gonna, at the seams, you're always gonna have points in the terrain that represent the same data, right? Unless, yeah, isn't that true? I'm just trying to think about ways you could do it without that being true. If you split up your terrain into patches, yeah, you're always gonna have the seams here. It's gonna have to be represented by the same data. I'm pretty much forced to splitting up my terrain into patches because I think it's gonna be so big that we want to represent these by different... The seam doesn't need to be halfway through a grid cell though. No, but you will still have the same problem if you don't do it like that, but you will be more... one sec. I see what you mean. I'm just trying to remember the reason why we did it like this. Yeah, I mean, he's not suggesting it shouldn't be split into patches. That I'm just trying to figure out why we did it this way. No, I think we're pretty much forced to do it this way. We wanted the... Now, okay, it comes down to this. Let's see if I can put this. We want different terrain patches. Each terrain patch is gonna keep track of its the relevant data for it. So just by laying that ground rule, I see what you mean. We could do... So you could do it the other way around, so that is still true, but then when we draw the actual patches, the vertices, for every edge vertex you would have to access 2 terrain data instead of just 1, right? So yeah, it comes with pros and cons, I guess, but like terrain seems is always a little bit of a messy thing to do, honestly, but I think this solution, this definitely works. It's just a question of is it the best solution. You could do the same thing though, add a bit of margin. Yeah, like all of this is very interesting to me, so I'm just trying to understand everything and every point of view. Basically what we do now is let me paint it like this. Let me paint it real quick. If we have, yeah, let's say that every patch we have is represented by a 2x2 texture, and we have this. We have a terrain base consisting of 4 patches, and each patch consists of 4 data values in a grid like this. The way we do it right now is, so yeah, this one represents the same value as these 3, and so on and so on. This one and this one. When we draw the terrain later on, or when we draw the actual mesh, we place the mesh vertices right in the middle. So what this actually is, it's actually a texture of, what do we have, 3x3. So this is the actual data, unique data, and when we draw the meshes here, we draw one mesh like this and the other one like this. This is the solution we're working with. In fact, I'm really trying to put this into... So we're basically working with an offset here, and yeah. I mean, your GIMP skills are worthy. Yeah. They are not perfect. Yeah, this definitely comes with its cons. We have been fighting one of the cons the entire 4 hours today, basically. but I think we have it solved. Yeah, I mean, I wouldn't like. Mine are pretty shit as well. But okay, let's see here. What I want to do now, we have this working for bounds. Basically, what I want to do is I think I want to split this up. We want to have one method that returns. Bounds is still not as descriptive as we want to go. We want to go deeper because we want to be able to send in colliders here eventually, I think. Basically, or colliders represented by their smallest building blocks. So for a sphere collider, we want to send in a point and a radius, and we want to calculate all of these indices given those two, and on and on and on and on and on. But yeah, like I would love to continue this today, but unfortunately I have to run now. It has been both annoying and very fun today. I like this indexing stuff. I'm not very fond of it, but it feels nice to have it sorta in place. But yeah, we're gonna continue this shit tomorrow. Yeah, thank you so much for watching, everybody. Appreciate it. All the input, everything. Have a great rest of the day. Peace.